Hi everyone, and welcome back to our algebra series on linear relationships. And in this video we're going to talk about some special lines and y equals mx plus b. Now we already know that straight lines can be described with this equation of y equals mx plus b, where the gradient is m and the coefficient of x, and b is our y-intercept, or where the line crosses the y-axis, and that we call this rule the gradient-intercept form. Now, if we have a quick look, we have our graph here. We have our line, and our line here is this equation. Alright, so this graph is y equals 3 over 2 x plus 1. And we can see that's all happening because our m is 3 over 2 and there's b plus 1. So we can actually identify this in our equation. There's our gradient, or m equals 3 over 2, and there's our y-intercept, or b equals plus 1. Now all this works really nicely, and it can help us create rules. So we can either find a rule from a line, or we can find a rule from some other information and create a line. Either way, we can actually use this as a really good tool, and it's actually really handy in the finance industry. Let's have a bit more of a look at what's going on with these lines. So as we said before, we do have the gradient-intercept form. Okay, and m and b are the constants of this, so they will not change regardless of where a spot is on the line. So let's make a quick note of that. M and b are constants in our equation. Alright, they don't change. They're not going to change, okay? Our gradient, obviously, is the coefficient of x. The coefficient being that number part of a term where there is a pronumeral. Alright, and then obviously our y-intercept is our value, or the point where the line crosses the y-axis. Or where the line crosses or intercepts the y-axis. Now, of course, everyone already knows this particular bit of information. If you're watching this video, we have gone over it many times. Now, there are some special lines that we need to think about and consider. We have horizontal lines. Alright, so horizontal lines are just a flat line that crosses somewhere on our y-axis, but it won't matter what the x value is, it will always be that y value. So it's just y equals b. So if you find that one, y equals b, you know it's going to be a horizontal line. Then we have vertical lines. Vertical lines obviously being very similar to horizontal lines, except for the fact that they go straight up and down. They only cross the x-axis, therefore they only have that one x value. And it doesn't matter what the y value is, it always will have that x value. And you can see, alright, there's our y equals mx plus b on our diagram. And if I do a better line, our x equals a on our diagram. Now, the only other one that we've got there is our line that passes through the origin. So if we have a line that passes through the origin, there's technically no y-intercept, or the y-intercept equals 0. So we don't actually have to include it in the equation when it equals 0. So lines that pass through the origin. So the origin being where our two axes meet. They have a y-intercept of 0, which leads to our y equals mx equation. That's all that's equation's going to be. Let's jump in now, straight into some examples so that you can get cracking on your own problems. Let's look at the first two. All we're going to do in these first ones is we're going to state the gradient and the y-intercept. We're going to identify them from those equations. Now, fairly simple. We know where they sit because we have y equals mx plus b as our equation. We know that's gradient. So whatever is in that part of the equation in the ones that we've got in our examples, that's going to be the gradient. And that part's going to be our y-intercept. So let's look at our first one. Y equals 3x plus 4. Well, 3, m equals 3. Whoops. Put in x instead of a 3. That was good. So m equals 3. And our b equals plus 4. So there's our gradient of 3, our y-intercept of plus 4. Let's look at the next one. Same basic idea. We're going to look at, see where that m part of the equation is and where the b part of the equation is, and identify those numbers. So here's our m part. Now, that negative sign actually belongs to the m part. So it is minus 3 over 4 for this one. And then here's our b. And for this case, b equals negative 7. Absolutely as easy as that in terms of identifying where those bits are of your equation. Right, let's look at the next one. We're given an equation here. We've given the equation, and we want to sketch this graph. We know what the gradient is. We know the y-intercept. First thing I'm going to do is I'm going to put some bits and pieces in my graph. Alright, so I'm just going to give it some scale here so that I know where all my numbers are going. And you'll notice it is only the first quadrant of the Cartesian plane, or the number plane. Now I'm going to pop in my y-intercept of 2. I know it's crossing the line at plus 2, so I don't need to do anything else with that. So there's my y-intercept. Alright, there's our y-intercept. It equals plus 2. And the actual coordinates of it is just 0 and 2. Alright, now for our gradient, so our m part. Alright, so if we remember that gradient equals rise over run, and that any number on its own, for example 3, can be written as a fraction as 3 over 1. So that's just the number 3. So from this information, we can see that for every one across I go, for every one step across, so one run across, I have to rise 3. So if I come across to here, so that's my one step across, that little blue dot. And then I go 1, 2, 3. There's my 3 steps up. That is all I need to be able to draw my line. So here is my ruler. Let's get the ruler on the spot. There it is, right there. And I draw through my spots and put my arrows in at the end. So that's all that line has to look like for our graph of y equals 3x plus 2. Now let me just fix up that little circle. It needs to go around the whole thing. Okay, let's keep cracking through this and get on to our next one. We're going to graph these equations. Now our first one, it looks like the y equals b option that we had before. So I'm just going to go up 2. There's my 2. I might put it in a better spot. Just get that in a better spot. There's my 2. And I'm just going to put my line across the horizontal. So there's my line, or my ruler rather, and I draw through that spot. Arrows at either end to say that it just keeps on going. That is y equals 2. My next one here is x equals minus 3. So this one is our vertical line. So before we had the horizontal line, and now we have the vertical line, and it's at minus 3. So there's my minus 3. So I need to go vertical. Move my ruler to the right spot. And just put the line through the point. And again, arrows either end to represent the fact that it just keeps going. Now we're at y equals minus 2x. Now if you remember rightly, up above we said that was one of our special lines. It doesn't have that plus b section, so that means it's going through the origin. So it has to go through the origin. Now our gradient for this one is minus 2. Now if I turn that into rise over run, I'm going to have minus 2 over 1. Minus 2 over 1. Just make my 2 a little bit better there. There we go. So for every one across, this time I actually need to go down 2. So if I put some dots in to represent, because I've got a negative gradient, I need to go down. Okay, so there's my minus 1, minus 2, minus 3, and minus 4. My 1, 2, 3, 4, and 5. So my first point goes through the origin. Then for every one across, I need to go down 2. So if I come across to here, I need to go down 1, 2, and there's a point. Now I can keep going until I run out of space, or I can just use those 2 points, which is what I'm going to do. Try and line up your ruler really nicely and draw through the points. Remember always to go through the points. Don't just finish at the points or you won't have a long enough line. There's those 3 examples right there. We have our horizontal line. Spell horizontal correctly. Horizontal line. Here we have our vertical line right next to it. And then we have our line through the origin. Okay, our last one there, we don't need to draw a diagram for. We can just use the equation that we have and substitution. So for this one here, we're just going to use substitution. Okay, just substitution. So we're going to start with our equation of y equals 2x minus 7. Now, the 2 and the 7 are going to stay right where they are. I'm going to substitute in the 3 for the x and the minus 4 for the y. And then I'm just going to use my algebra. So I'm going to go minus 4 equals, should have been 2, sorry about that. 2 times 3 minus 7. So minus 4, 2 times 3, well that's 6, minus 7, well that's minus 1. You can see there that it is not, in fact, equal. Not equal. So the answer to our question is no. Because that doesn't work out, that point does not lie on that line. If those two sides were equal, it would lie on the line, but it doesn't, so no. The point 3 minus 4 does not, helps to spell things correctly, lie on the line y equals 2x minus 7. That's all that needs. Hopefully you have gotten something out of this video. It has helped you a little bit there for the time being. Good luck with the questions that you're about to do and all future problems, and thank you for watching.